Welcome to this episode of our matrix lessons. So this takes you through the introduction to matrix and um, very few things you're supposed to know about matrices. Okay. All right. So a matrix is a rectangular array of numbers, and the numbers that are in the array are called the entries in the matrix. Okay. So this is what I mean by matrix. So you have some rectangle, and then you have some numbers represented in them. Okay. And these are the entries of the matrix you're talking about. Okay, so an example is this matrix here. This is a matrix. This guy is a matrix, and that guy is a matrix. So in matrices, we have something we call rows and columns. Okay, so if I write a matrix A, and like this one I have here, 204, then all the entries you read in a horizontal way, okay, are what we call the rows. Okay, so these are the rows and row entries. So we name them one after the other. So I can call this one row 1, row 2, and then row 3. So in row 1 I have the entries 1 and 2. In row 2 I have 3 0, and then in row 3 I have negative 1 4. Sorry. All right. So we have other part of it, same A. We have something we call the columns. Okay, and that is all the elements you read in a vertical position or vertical way. So here we have two columns, column 1 and then column 2. So in column 1 we have the elements 1 3 -1, and then in column 2 we have the elements 2, or maybe the entries 2 0 4. Right. So that is what we mean by matrices. And you refer to a matrix, we have the dimension of a matrix. You mentioned the number of rows and the number of columns. So in this A that I picked, the number of rows I have here is what we have, 3 of them, and then the number of columns is 2. So this is a 3 by 2 matrix. Okay, so that's the dimension of this matrix A. So if I come to the matrix C, how many rows I have? 1 2 3, and then the columns is 1 2 3. So I have a 3 by 3 matrix. If I come to the matrix B, I have how many rows? Only 1 row. And I have how many columns? 1 2 3 4. So I'm going to have 1 by 4 matrix. So always the row come and then by the column numbers. When you come to the matrix D, how many rows? You have 1. How many columns? You have 1. So I have a 1 by 1 matrix. And all 1 by 1 matrices are constants or scalars. Alright, so every scalar is a 1 by 1 matrix. That's how you can take it. Now a square matrix, I'm so sorry. So a square matrix here was supposed to be is a matrix with same number of rows and columns. All right. So an example of that is A being equal to 2 1 3 4. So this we also read matrices along the rows, the entries in the matrix. So 2 1 3 4. So you just read the entries along the rows. Okay. So here this is a 2 by 2 matrix. This is also a 3 by 3 matrix. Okay, so when you have the same number of rows and columns, then your matrix is a square matrix. Now let's look at another property of a matrix called the diagonal elements. If I have a matrix A11, and this is a general way of referring to a matrix, okay? So you call the entry of a matrix Aij. I mean, this is a more abstract way. But here, ask yourself, how many rows do I have? I have 3 of them. So this is row number is 3, and then the column number I have 3 as well. Now if I have Aij, what I stands for is the row number, and then J stands for, this is row, this is column number. So A11 here means that the matrix at the entry of A at the row 1 and then column 1. That is what I mean, A11. So row 1 column 1, I have the entry to be A11, and row 1, the same row 1 column 2, and this is column 2, right? This is column 1, this is column 3. Row 1 column 2, that is A12, that is that element A12. Right, so that is what it means to have A11 and the rest. Okay, the diagonal elements are the elements such that you have Aij such that I is equal to J. So in that case, I'm talking about the A11, A22, and then A33 in the case of a 3x3 matrix. So if you had a 4x4 matrix, then you're going to have an A44 at the latter part. Okay, so when you have all the elements or all the entries just in a diagonal like this, okay, so you can actually look at it that in a square matrix, that is how it comes. In the previous ones, if I want to talk about the diagonal, mostly I have to get a square matrix like this. Okay, so all the entries in this diagonal, those are the entries we refer to as the diagonal entries or the diagonal elements, okay, of a matrix A. So in an example of B here, the diagonal, in this lessons I'm going to use diag of B is going to be the elements 1, 5, and then 9. Okay, so all the elements here. So in this case, B11 is equal to 1. That is the entry of B at the row 1 and column 1. B22 is also equal to 5, and then B33 is equal to 9. Okay, so that is what we mean by diagonal elements. Okay, so what is an upper triangular matrix? An upper triangular matrix is a matrix such that you have some elements here. So maybe let me restrict myself to a 3x3 matrix, and this is A12, this is A13, this is A23. You have these elements there, and then the rest of these elements are zeros. So an upper triangular matrix is a matrix that all the elements just below the diagonal are zeros. So what I mean is all these elements here are zeros. Below the diagonal entries are zeros. It can happen that you would have A11, a 0 here, and maybe A13. What I mean is you're gonna get some values, or maybe let me use actual values for you to know what I'm talking about. This is a diagonal matrix. Sorry, an upper triangular matrix, sorry. Maybe 0. I'm gonna have maybe another 0 here. I'm gonna have 1, 0, 0, and then maybe 3. This is an upper triangular matrix because if you take all the diagonal entries here, every element below that is 0. That's what we call an upper triangular matrix. We have a special type of an upper triangular matrix, or maybe an example of such a type is this one. And this is called a diagonal matrix, and this is an upper triangular matrix because you can say that every element just below the diagonal is 0. So you can say this is an upper triangular matrix, but this is a special type called a diagonal matrix. So diagonal matrix is matrix with every element 0 except the diagonal element. So the diagonal elements are not zeros, but all the other elements are zeros. With that said, it doesn't mean that this is also let me give another example of a diagonal matrix. This is a diagonal matrix because I have everything here, so everything above and below the diagonals are zeros. So this is a diagonal matrix because everything above and below the diagonals are zeros. Again, I'm gonna pick another matrix, the 0 matrix. This is a special type of a diagonal matrix because every element below the diagonal and above the diagonal are zeros, just that the diagonal elements are also zeros. We have a lower triangular matrix, and of course that one has every element above the diagonal to be 0. A21, sorry, let me erase that. A21, A22, and then 0, A31, A32, A33. So if you happen that all the elements above the diagonal are 0, then you have a lower triangular matrix. So you have your values to be at the at this part of the matrix. An example of such an such a matrix is also, you can think of this 0, maybe 0, 0 again, maybe 2, 0, maybe 3. Once you're able to see that every element above the diagonal are zeros, then this is a lower triangular matrix. Again, a diagonal matrix, okay, 0, 0. A diagonal matrix is also a lower triangular matrix because if you draw the diagonal, every element above it is also 0. So a diagonal matrix is actually a lower triangular and an upper triangular matrix. Okay. The trace of a matrix is what we call the summation of so you can say the summation of aij let me j start from something 1 to wherever you want to see, and so in this case we have a 3 by 3 matrix, so it's going to be 3 here, right? And so that is what I mean. So the trace of a matrix is the summation of all the diagonal entries. Okay, so in this case the trace of A is going to be I'm so sorry, I'm supposed to write a 3 here. 3, 3. So trace of A is going to be A11 plus A12, A22 plus A33. The way to see this summation will be first summing along, so J is starting from 1 to 3, summing along I, you're going to get A1J plus A2J plus A3J, because I is starting from 1 to J, 1 to 3, and so if you sum along J2, you're going to get A11 when J is 1. What I'm doing is I have to define this variable where I is equal to J. So whenever they are the same, so you have to specify that. If not, you're gonna get a very confused thing here. So plus A22 plus A33. So we are interested in the part where I is equal to J, right? So in this you have to add it to it, I is equal to J, before you can perform this summation. And yeah, that is it for the introduction to matrices. Especially with this one, the trace of matrix, I'm going to take in the next lesson, I'm going to take the properties of that and some basic proofs you can write out of the trace of a matrix. Okay, so thank you, and don't forget to subscribe to my channel if you have not subscribed yet. See you.